Dear student, I have started again. I'll welcome back to the pre-video of this is a second pre-video of module 3. So last video I have discussed the definition of context-free grammar. So again I'm start with the refreshing the last video. Where did I stop my class in the pre-video of first video, that is the introductory video. So we have stopped the application of context-free grammar as discussed in the previous video. Syntax of programming language, which is main application will be used, context-free use in the context-free grammar is used in the syntax of programming language. And CFG is also you can use it for developing a parser. So today new topic on context-free language. So as I told you, for exam point of view, you have to write what is context-free grammar or CFG. You have to tell it is defined by 4 tuples denoted by G, V, T, P, S. We know what are those symbols as explained in the previous video and also explained in the previous slide. Today video, right? Look at that. I'll continue for this today class. I'll write how can be generated. This context-free grammar is generated. The language generated by grammar is also very important. Let G is equal to VTSP be a context-free grammar. CFG, right? CFG. Then the language generated by G is L of G is X belong to T star. T is nothing but a terminal, string of terminal. So that string is a G. Condition is S derives the some kind of grammar from X. That is nothing but a language L is a context-free language, CFL. If there is a CFG, so that L is equal to L of G. Any grammar is generated. If the grammar or any grammar is there, definitely some kind of language is generated, or any language you can able to write the grammar. So that is the meaning of this grammar. Let us see some of the example in this, how that will be work. This is very important. You can expect some questions on this video or in this slide, 4 to 8 marks. Right, so we have seen this already in the previous module, that is module 2, how to write a regular expression for particular language. Similarly, write a CFG for either E or B. In this statement is, so grammar is either A or B. So how do you write that? Means it is A or B, it is E or B, right? So what is that? One of the symbol must be there in the context-free grammar, that is start symbol. S gives, it is a kind of derivation or grammar, either A or B, right? That is the meaning of it. I started with a very simple example. Move on to the complicated one. Now you all see this also expression. What is that? Write a CFG for A plus. What does it mean here? It can generate a string is at least one A or AA or AAA and so on. It is generate a finite number of A's. At least one A should be there, right? But so number of A's generated. Again you have to start with S. You have to fix it. One A should be there. So at least one A should be there in a string. That is valid. It can be have generate 2 A's. How do you do that? A. So again yes, right? S can be start rotating itself. It can be number of A's is as increases. S can be substitute one again and again, right? Take this. How do you generate the 2A? Look at this. I'll start with S. I want to generate 2A. I'll take S. What is the one more rule of A? There are two rules are there. S gives A. Another rule is gives AS. Right? 2. So I want to substitute because I want to generate 2 A's. A. This A is substitute by what? Yes, rule number 1. Okay, now we have generated 2a. Suppose I want to generate 3a. How do you do that? Again you have to start with as rule number 2 or rule number 1. S gives a, again as. If I substitute only s by first rule, you will get only 2 a's. If I want to generate 3 a's, right? So a. Right? This s is replaced by first rule, right? So now 3 a's. Like that it can be generate any number of a's. So that is the meaning of this grammar. Now let us see that. I got it right. Now let us move to the next one. So which is similar to the previous one. What is the string is here? What is string as generated from this regular expression? Write a CFG for this a star. So first of all, bus string is epsilon. Then what is the next one? A, then a, and infinite number of a's will be generated. Then I have to fix it. What is that? First epsilon I have to fix it. Is generate epsilon. It can be any number of a's come, right? It is, so there is a epsilon, one a is generated, it will generate this one. Suppose only a has generated, one a is, so s is replaced by what? Epsilon, right? What is the value you will get? Only a will get, right? So then what is the result for this? Got it? Then how do you write this? You use the previous knowledge of this a plus a star. You can write it directly. Now you tell me, what is that? First, at least epsilon should be there, right? You fix epsilon. What is that most? After that, any number of ab can be start, ab, and so on, right? So then ab, 1 ab has come. Suppose if you want to generate a 2 ab, yes, you can put it, right? Got it? Right. Next, write a CFG for any string of a or b. Right. Look at this. Any string of a or b. So one string should be there, or it can be b. It can be ab, or b, a, or ab. Right. How do you write it? So it can be any number of a or b. First of all, any number of a's, it can be rotated any number of times. A, B, A, AB. So then you can take one more rule, AS or BS or AB. Right. Let us move on to the next one. Here it is. At least one A. What is the string it can generated from here? What is the string it can generated from here? Now you tell me, what is that string? It can be A, AB, it can be A, B, it can be A, B, and so on. This is a string. Now you tell me, at least one A should be there, right? One A should be there as generated, as gives A. Another rule is what? Right? Another rule is I'll put like this, A, right? A, you can write AX, you can write, sorry, I'll write it like this. First, okay, please, right? Look at this. I'll take this AX, right? So what is X here? X could be, again it is a B. If this is A, this is I take X variable in place of that. X again it is BX or epsilon, right? Which is similar to the A star we have seen in the previous slide. Look at this, AX or BX, right? Right. Then what is this exactly? I'll take, here it is, I'll take this X and Y. Then S gives X, Y. What is X here? X is A star. You know already how to write a star. A X. Then what is Y? You know already how to write a B star. Epsilon B Y. Look at this. These are the grammar for this regular expressions. Okay, got it? Then how to write this? This is very simple. Very simple one. You can write, what is that? One it has S gives epsilon. Another one is it can be generate any number of A's and any number of B's. So what is that? It can be any number of A's or any number of B's or epsilon. You know this value already. Then it is what? You can take S A X. X could be any number of Ax, any number of B or 0 times. So which is very simple. Okay. Now let us move to the next one. Either write a CFG for A star or B star. How do you write? A star or B star? So you can take S gives A or B, or what is that A? A gives, you can take any number of times of A or it is 0 times. Or B star, it is nothing but it can be 0 times or it can be any number of B. Which is similar to the, again you can take separately, this is X or Y, any name you can give, or AB. You can take this, it can be 0 number of 0A or 1A or epsilon. This is also similar, 0 1B or epsilon. Write a CFG for balanced parenthesis. It may be it is open parenthesis, there may be must closing parenthesis, it may be square bracket, there should be a closing bracket, it may be a brace, okay, curly bracket, opening curly, closing curly. So these are the opening, right? If there is no, suppose this is the grammar for parenthesis, right? You can state like that. It can be generate any number of times closing parenthesis, right? Or you can curly braces are open any number of. If there is open any curly brace, there must be a closing curly, right? Like that, right? Write a CFG which contains at least 3 times 1. So that means what? Over the alphabet 0, 1. You have to assume that there is everything, while giving a problem, that may be there is a 1, they will mention alphabet over the 0 or 1 or A comma B. So there is at least 3 times it has to be 1. It can be have more than 1 or zeros. What is A? A can be, it can generate n number of A's, n number of ones, or at me epsilon. So CFG that must write a start and end with the same symbol. So similarly can be regular expression, start with 0 and end with 0. If start with 1, it can be end with 1. Or it can be start with A, it can be A. Or it can be start with B, it can be end with B. So this is the way they may ask in exam. This is very important question. Look at that. It start with 0 and end with 0. Or it can be start with 1 or end with 1. What is A? It can be any combination. 0 or A, 1 or A. Any language of even and odd length palindrome starting over palindrome string over A comma B. Look at S gives A S A or B S B or A bar B. Right? How do you do that? It is epsilon. It can be epsilon. Palindrome. It is suppose any word is start with that letter, end with the same letter. If it is start with the B, it can be end with B. If it is A only A. If you reverse the string, you will get the same string, right? So that is the reason of that can string. Language of even and odd length palindrome string over the alphabet. If it is a odd length, it is only A. Okay, if I rotate it, if it is B or it can length will be A. And epsilon you can take, if and reverse it, you will get the same string. Right. So if it is even length, right? A, right? Okay. Yes, A. So it can generate both, right? It is substitute epsilon, you will get A. If you substitute A, you will get odd length, right? Or you can substitute 2 times of A or B, you can get odd length or even length, right? Number of A and number of B are same. How do you write? It is same. AS, B or BS, A or epsilon. Any order, you can start and end with that. So language of A comma B ends in A. Always it is ends in A. S gives AS or BS A. It is always ends in B. Ends in A. Sorry, ends in A. So here it is always A. S has come at the end and BS. So it is always ending in A. Okay, we'll see some of the example you can be able to write. A bar B star. So you can take all this, right? You take down this, all this are in homework. I have given some of the example. We'll all discuss in detail in the blackboard. With this, I will be winding up the second pre-video of the module 3. Thank you.